Okay, so 2 minutes past 11. So, in the interest of time, we may as well get going. So, Fran, just to check, can you see my screen there?
Yeah, we can see your screen.
Excellent. So, no mai haere mai. Welcome to our webinar on real-time GIS. In today's fast-paced world, timely and accurate spatial data is crucial for informed decision-making. Real-time GIS integrates live data streams with geographic information systems, enabling organisations to monitor, analyse, and respond to events as they happen. So join us today as we explore the fundamentals of real-time GIS. We'll showcase some practical applications across industries, and we'll discuss the ArcGIS tools and technologies driving this transformative capability. So whether you're in urban planning, environmental monitoring, emergency response, utilities or logistics, this webinar will help you discover how real-time GIS can elevate your operations. So without further ado, let's dive into the power of live spatial intelligence. But first, we better introduce ourselves. So my name is Dan Clark, and I'm an account manager at Eagle Technology. I've been a GIS professional since the late 90s, starting out with ArcInfo Workstation, command lines, ArcView 3.2 and Avenue. So not sure if anyone remembers those, but over the last 25 years, I've really seen the incredible evolution of GIS as it continues to advance rapidly, with real-time GIS being just one of the many exciting developments. And joining me today on this webinar is my colleague Fran. Fran, you want to please introduce yourself?
Yeah, so hi, I'm Fran Arancibia. I'm a solution engineer in the technical solutions team at Eagle, and I'm based in Wellington. And I've been a GIS professional just for a year, so I'll pass back to Dan now.
Excellent. So what have we got in store? Well, here's a quick look at what we'll cover. We'll start with a big picture introduction into real-time GIS, discussing what it is and what matters. Next, we'll work through key workflows, showing how real-time data is integrated and applied in practical scenarios. We'll highlight the powerful tools ArcGIS offers to support live data streams, including monitoring and alerting. And then get ready for, I suppose, a bit more of a technical explorations of real-time GIS as we do a deeper dive behind the scenes. And then additionally, we'll provide resources to continue your learning after the webinar. Finally, we'll conclude with a live Q&A session where we'll answer your questions and address specific use cases. So I'm sure you will have questions as we go. So to do this, you should find a question panel on the right-hand side of your screen. Feel free to ask questions at any time throughout the webinar, and we'll do our best to address these at the end. So we're excited to have you with us. So let's get started. Our world is increasingly connected. The technologies we use in everyday life, smartphones, smart sensors, Internet of Things, or IoT devices, live data feeds, are constantly producing data. These data streams continuously capture and share real-time information about a variety of conditions and events, including things like weather, traffic, asset status, incident alerts, personnel and vehicle locations, and more. So as real-time data has proliferated, more organisations across all the different sectors are looking to this data as a source for insights that support their business and improve their decision-making. There's also been an explosion in connected devices. Devices are becoming cheaper, allowing more organisations to purchase and deploy at less cost. So this plays into the growing ability to construct relatively comprehensive digital twins of a physical system, monitoring any aspect that's needed. But also devices are becoming smarter, allowing people and businesses to not only record observations, but also perform actions and trigger alerts based on those observations. Much of this data contains location information that can be managed, visualized, and analyzed using GIS. Organizations make decisions every day that require them to understand and react to quickly changing circumstances. These decisions help them keep their operations running smoothly, avoid damage to assets, prevent disruptions of service, and can even save lives. To make these informed decisions in these circumstances, they need situational awareness, and that level of awareness really does require real-time data. These organisations may be interested in applying real-time data to monitor personnel and vehicle locations, to take action to maximise efficiency and keep people safe, or to optimise operations by managing the health and performance of assets, including systems, equipment, and vehicles, or to protect that critical infrastructure from outages and threats, or to understand historical behaviour and event patterns to guide future decision-making. For example, real-time data about personnel locations can be combined with information about the immediate environment around them to keep them safe. So you can gain insight from movement analytics and optimise staff allocation. And more broadly, businesses of all types want to monitor, manage, and optimise their assets. So whether that means managing a fleet of vehicles or allocating and tracking valuable hospital equipment. Many organisations also want to leverage contextual information to protect critical infrastructure by detecting, locating, and isolating areas at risk and responding in near time. And in the utility space, there's SCADA integration and operations monitoring. In agricultural and environmental markets, there's plant pest monitoring, air quality monitoring, water monitoring, and so on. And in transportation, there's an increasing number of roadway sensors and connected vehicles. So the list really goes on and on. But with all this real-time data, it can be overwhelming. It's created at a very high velocity, meaning the data is updated quickly, sometimes multiple times per minute or even per second. It's also high volume, so the data sets can grow to be very large, often too large for your traditional databases or data stores and analysis tools. So as a result, organizations may have lots of real-time data, but they may not have the tools required to handle the velocity and the volume of that data. So what this does is it really limits their ability to understand the data and use it to guide good decision making and to take action to protect their people and property and so on. But building systems that can take advantage of this high volume, high velocity data is challenging. These systems need to be highly available, scalable, and resilient, while also being easy to configure and maintain. So ArcGIS addresses these needs and challenges by helping organizations manage, monitor, map, and analyze real-time data from a variety of sources. In turn, this allows users to tap into high velocity, high volume data streams and gain the insights that support their business. So what is real-time GIS? Well, in the context of ArcGIS, it's a capability of ArcGIS that lets users apply streaming data to improve situational awareness in real time. And these can be things that move, sensors that send readings, or things that just happen. So it's a capability across ArcGIS, just like 3D, indoor, and imagery capabilities are across ArcGIS. By bringing real-time data into ArcGIS, organizations can more effectively monitor, understand, and respond to rapidly changing situations. So they can connect to data from a variety of feeds, view this data in live maps and dashboards, and apply spatial analysis to get quick answers that support their decision-making. They can also automatically initiate alerts and system behaviors in response to triggers they define. So these capabilities help organizations take informed action immediately when something happens. So let's take a quick look at some of these use cases. Real-time data is more than just simply tracking dots on a map. It's about using analytics to gain this greater situational awareness to support your organizations and operations. So these real-time insights can help you with asset management. This is where you can track the location of vehicles and vessels, helping you better coordinate fleets. You can analyze the status, location, activity of personnel to help keep your people safe and productive. And by improving your awareness of goods or services as they move around, you can better manage your supply chain. And of course, you can analyze key metrics related to fixed assets and trigger actions when critical thresholds are met, helping you protect your infrastructure. But the real-time analytics can also improve threat monitoring. So think about things like special events. During these, you can provide real-time information to safety personnel and first responders, help them respond quickly to incidents if and when they arise. We all know climate change is here, so when severe weather strikes, you can see where potentially dangerous conditions exist and take steps to protect your people, assets, and infrastructure. And ArcGIS provides security with a single pane of glass from data for data from multiple feeds, and this could be things like CCTV, social media, and other live data. And of course, emergency management agencies can push real-time data into a single view for an operations centre, so resources can be dispatched where they're needed most. So now I'll hand over to Fran to take us through just a demo of a downloadable configurable app from the solutions.e3.com website that combines real-time feeds for situational awareness and also gives us a quick behind-the-scenes look at ArcGIS velocity. Over to you, Fran.
Thanks, Dan. I'll just share my screen. Sweet. So, make sure that my screen is sharing. I'll start by introducing the ArcGIS Watch Center, which is a solution designed to streamline all hazards event monitoring in key locations. So the Watch Center itself consolidates real-time event feeds and creating alerts for locations of interest, allowing you to monitor and evaluate potential threats and hazards effectively. And for those unfamiliar with ArcGIS solutions, these are collections of templates, tools, and resources that enhance the ArcGIS software. And in public safety, they offer ready-to-use maps, apps, and tools to improve situational awareness, resource allocation, and community safety. However, they're all fully configurable and applicable to any domain or use. So here's the Watch Center. During an event, your organization would leverage it for more professional purposes, and it summarizes all the purpose of the solution, provides additional information, and here you can see some of the event feed providers that the solution can work with. Now, this is not an exhaustive list. There are many other providers of events and feeds out there that that can be consumed. One of them is Signal, for example. Deploying solutions into ArcGIS Online is as easy as clicking the Deploy Now button that you'll see at the top. And they're also available for ArcGIS Enterprise. And deploying just takes a couple of minutes, and you can start using it immediately or configure it to meet your specific needs. So let's have a look at the Watch Center itself. So the app is built with ArcGIS Experience Builder, and the starting page is a dashboard, giving users an immediate view of what matters most to them. So the summaries here are from various watch areas, and the datasets are set up by S3 for demo purposes. But as mentioned earlier, this is fully configurable. So in your own setup, watch officers could see trends and areas relevant to their needs and locations. And now imagine I'm a watch officer with a new location to monitor. And as you can see, various links at the top right of the screen, we'll start by setting up a new watch area. So on the left, you see a list of the currently monitored areas, which most are in the US. But here, because we are a hardworking watch officer, we've already set up a watch area for the New Zealand User Conference that just passed this last month. So on the right, you see all the details entered in this location. And a top tip here is to fill out as much information as possible to help other organizational users understand what the location is and why it's being watched. You'll also notice the 10-kilometer buffer to the Takina Conference Center to then capture any events within this area. So now by clicking the Monitor Alerts tab and zooming in, we can see the buffer applied and any events occurring within it, as provided by our sources that we saw earlier. So there aren't many events happening, but we can still use this one event to demonstrate the capabilities. So the description of this alert tells us that people attending the conference might have difficulty arriving on time. So I need to make sure that the decision makers are aware of the situation so that they can send out communications for alternative routes. So now clicking this button, Create Watch Report from Alert, brings out this Survey 123 form, which is pre-populated with much of the information directly from the source. And then in the Manage Watch Reports tab, I can then update the details or delete the watch reports if needed. But crucially, I can also use this to communicate with stakeholders. So at the top of the information, there's that button to email watch report, which opens up a template with all the information that the stakeholder might need to make a decision. And the recipient will receive that link to a dashboard, allowing them to view the report in a spatial context and then better understand the situation. So that was the front end and how it supports situational awareness. But this is the back end that powers it. So we can use ArcGIS Velocity to use the event feeds that have massive amounts of global data that we need to filter out the noise to focus on what matters. So Velocity, as we mentioned earlier, is a real-time and big data processing tool with analysis capabilities in ArcGIS Online. So working with Internet of Things sensors can get pretty complicated pretty quickly, but the Velocity has been designed with users in mind, so it's a pretty straightforward app. And what you see on screen right now is the real-time analytic that sits behind the Watch Center. So here you can see the incoming feeds from different providers. As we zoom in, and you'll also see a couple of other feeds like wildfires and earthquakes. These you can find in the Living Atlas. So what Velocity is doing here is normalizing the data so it can be combined into a watch alert that we saw in the watch center. And as you can imagine, these providers aren't beholden to one another, so they contain different data from one another. So velocity is mapping these fields that then these features arrive in the field in real time. It then merges these fields and ingests the watch areas created by our imaginary watch officer. So all of these get turned into a calculation where some arcade action is happening to filter out the events beyond a specified buffer distance until we end up with our watch alerts we saw earlier. So these can now be used in many different apps across the platform, in which the watch center is just one. So this is a relatively simple example of velocity. But on the left, you can see a range of different operations available when configuring analytics. So it's important to keep in mind that this is just one configuration. So you can add feeds from providers you're interested in very easily and perform different types of operation. So that was a quick tour of the watch center powered by ArcGIS Velocity, where you see the power that real-time and alerting can bring to your organization.
Thanks, Fran. I'll just get myself organized here. Excellent. So what we just saw with the watch center is how we work with real-time data in three ways. So first, you can ingest the data by establishing the feeds that connect to the observations from those sensors and IoT devices. Second, you can visualize, analyze, and enrich your real-time data, allowing you to provide additional context and analytic insight. ArcGIS supports analytics in real time for immediate answers, in near real time to schedule an analytic that runs on a recurring basis, and over time for trend analysis on archived data, which is very useful for planning and prescriptive workflows. And third, you can trigger alerts and notifications, such as text or email, or even actuate downstream processes, such as kicking off a work order. So let's take a look at some of these capabilities. As we saw on the previous slide, first we need to ingest the real-time data streams. So ArcGIS lets users connect to virtually any streaming data from stationary sensors, GPS-enabled assets, and live event feeds as a GIS data source. And once users ingest this data, they can then visualize the real-time information through live maps and dashboards, like we just saw. And they can also store accumulated data and share observations of interest. So this makes it possible to incorporate, the high-volume, high-velocity data feeds into business workflows, so people can use that data for their decision-making. By seeing this data in real time as it comes in, you gain that common operating picture that helps you track your assets, monitor live observations and events, and improve your real-time awareness. By bringing in real-time data into ArcGIS, users can see what's happening and where it's happening. So this allows them to monitor the location and status of, like I said before, personnel, vehicles, and assets. And as new data flows in, they can track dynamic changes, incidents, and events as they occur. So they can incorporate data from multiple sources to unlock this additional context. It also enables users to filter incoming data based on criteria they define, so they can focus on the most important observations. So as Fran said, filter out some of that noise. Together, these capabilities help improve situational awareness throughout the organization. For example, ArcGIS Velocity can automatically flag positions reported within a geofence, calculate motion statistics for moving devices and vehicles, and detect incident conditions in real time. Take informed action the moment something happens. So this is about helping organizations using real-time data to respond quickly when urgent situations arrive. Seeing real-time data in the context of other operational and enterprise data, so all your other layers, makes it easier for people to make informed decisions immediately. ArcGIS can trigger automated alerts and system actions when critical thresholds are reached or specific patterns and trends are identified, speeding up your response times. So these alerts push information to systems, sensors, and devices to prompt actions, changes, and responses. For example, you can send an email or a text notification to personnel, store data for further analysis, or trigger actions from IoT devices in the field. Uncover hidden patterns. So ArcGIS provides the tools for applying batch analytics to large volumes of data collected over time. So this helps users make sense of data sets containing millions of records. They can identify the historical patterns, the trends, the relationships, and reveal new insights that support decision-making. For example, you could identify anomalies that indicate unusual or suspicious activity. This also allows you to analyze data at scales that weren't previously possible, so you can understand historical patterns across space and time. Find those hotspots, find those anomalies, and get answers for your decision making. And you can run big data analytics pipelines on demand or schedule them to execute on a recurring basis. You can perform big data analytics on IoT data you've stored in ArcGIS, or in fact with big data storage systems like your Amazon S3s and your Azure blobs. And of course, once you've completed your big data analysis, you can share your findings with others. So ArcGIS lets you disseminate information in the way that's best suited to your workflows, pushing out to a dashboard, for example. You can publish analysis results as feature layers, which can be easily viewed in ArcGIS maps and apps. You can also write these results to external services like Kafka or RabbitMQ, or store them in the big data systems I just mentioned, like Amazon S3 and Azure Blob. So ArcGIS offers software, apps, and data that provide real-time GIS capabilities, and these are broadly ArcGIS Velocity and ArcGIS GeoEvent Server, which enable real-time capabilities in ArcGIS Online and ArcGIS Enterprise. And then there are apps, data, and tools that are commonly used in real-time workflows, which we'll cover later on. But on the slide, you see that we have ArcGIS Velocity and ArcGIS GeoEvent Server. ArcGIS Velocity is an optional organizational capability that delivers that real-time and big data capability in ArcGIS Online. So it provides a cloud-native SaaS solution for ingesting, monitoring, and analyzing data from real-time feeds and historical data sources. It also lets users store accumulated data as big data and run the fast queries and analytics on the data. So the ability to deliver these capabilities in a SaaS environment means users can get started with real-time GIS quickly without needing to deploy and maintain the infrastructure themselves. ArcGIS GeoEvent Server, on the other hand, is a capability server that provides real-time capabilities in ArcGIS Enterprise. So it provides a self-hosted server-based solution for ingesting, visualizing, analyzing real-time data. And because often real-time data can be sensitive, the option for a self-hosted solution is great for organizations to deploy these real-time GIS capabilities in an environment that they control. So this means that they can meet their critical security and privacy or regulatory requirements. Unlike ArcGIS Velocity, however, ArcGIS GeoEvent Server only supports the real-time analytics and not the big data analytics. So to do that, you'd also need to plug in the GeoAnalytics server to provide that, which is also a capability server for ArcGIS Enterprise. However, coming in 2025, or to private beta at least, is ArcGIS Velocity for Enterprise, and this will be available for Windows and Linux. So I'm going to hand over to back to Fran for another quick demo on how to add a feed in ArcGIS Velocity.
Sweet. Thanks, Dan. Cool. So yeah, in this demo, we're going to create a feed in ArcGIS Velocity using real-time UV data from NIWA. But first, we can take a better look at the different elements in Velocity. So as I mentioned earlier, it's a pretty straightforward app. And this is the home screen where I can see my recent tasks. I can get started by creating a feed directly from the home page. Or if I've already created feeds, I can start creating real-time analytics or big data analytics. We also get a handy help tab to quickly access some helpful resources. And then at the bottom, we have this subscription usage tab where you can monitor your current usage metrics. And this is super helpful for understanding and tracking your consumption over time. This way you can identify trends like peak usage periods, and you can assess whether you might need to upgrade your subscription or adjust your usage strategies. Additionally, if you're approaching any limits, the tab will alert you so you can take the necessary measures before any users start experiencing issues creating new items. So now let's create a feed using real-time UV data from NIWA. And as you may know, UV radiation levels can fluctuate throughout the day and across different locations, making this real-time data essential for public health and safety. So I can start here. I will go into the input tab and click on feeds. where I can access all my existing feeds and create a feed from here. So once I've selected to create a feed, we need to select what type of feed. And as you can see, there are many different options available. But for our purposes, we'll choose the HTTP feed because we'll be pulling data from a web endpoint. So I'll choose HTTP puller. And from here, I just need to provide the URL, which I've already done here. Make sure you have the right URL. And if needed, you can define the request method. We typically use get method, which allows us to retrieve the data without making any changes to it. For authentication, I've put none. And this is because I've supplied my API key in the custom header. And for URL parameters, I have the location from which the UV data will be fetched. And the other parameters I've just left as is. And click next. So next we define the data format and schema. And since NEWA provides the data in JSON, we'll just leave that as that. And as we can see, the data is coming in many different fields, which gives us a time field and a UV value for each time. So one for each hour. And in here, I can change the field names or change the field type. But again, I'll just leave it as is and click next. Next, we identify the key fields. So in this specific case, there are no location fields because as we saw earlier, we defined the location in the URL parameters. But if there was a location field, we could select that. I'll choose none. And the data does have date fields. I just need to make sure that the formatting is correct. And no track ID. So next we'll set the polling interval for the feed, which determines how often ArcGIS Velocity will check for new data. So for real-time monitoring, you might choose this, set this for every minute, or you can even go for every few seconds. But here I'm choosing just every hour. And setting that setting is key for ensuring that your data remains current and relevant, particularly for something as time-sensitive as UV levels. So after configuring that and clicking next, we just have to name our feed and give an appropriate summary, and then we can save it, and we've created our feed. So once we've created our feed, we can start using it for real-time analytics or big data analytics. But I wanted to show what that looks like in a map once we've created our feed, which is viewed as a stream layer. And we can see that green icon there showing that it's active and it's working. However, I can't see it on my map. It should be around here. And this is because there was no location field. So what I've done to be able to see that in a map, and I'll go more in depth on this in our next demo, but creating a real-time analytic and using that feed that we've created, I've just calculated a field which gives that location, adds that location to the data, and then creates a layer with the feed and the location field added. So now I have the UV data geo-enabled, which is essentially the same data that's coming from the feed, but now I can use it in my map and I can see the location. If I click on it, I can see all the different UV values at different times, and I have many observations have accumulated over time. So there we've created a feed in ArcGIS velocity using UV data from NIWA. I'll pass back to Dan now.
Excellent. Thanks, Fran. That's great. Just checking I'm muted there. So we've seen a little bit there about how it works and how we can work with this data. So as you saw there with ArcGIS velocity, and the same applies to ArcGIS GeoEvent as well. There are new items that you'll access like feeds, and then there's the real-time analytics, the big data analytics, and you can manage those just like you would any other layers and maps and apps. So using ArcGIS velocity as the example here in the slide, it complements the IoT platforms by enabling you to easily bring in sensor data into ArcGIS for geospatial reasoning. That is to say, it works with sensors that are being deployed out in the field and being increasingly onboarded and connected to IoT cloud platforms and frameworks like Azure and AWS. Velocity can subscribe or query these platforms directly without requiring developer integration. Sensors could also drive data directly to Velocity over a REST endpoint, for example. So these capabilities of ArcGIS Velocity are surfaced through a few new types of items in ArcGIS Online. They're the feed items that allow you to receive sensor inputs. And as we just saw, they're user configurable components to make these connections to real-time data. And then there's real-time analytic items that allows you to perform real-time processing of those inputs, including training alerts and actions. And as we just saw, adding a location to a feed. And with big data analytics, or big data analytic items, users can access and analyze big data repositories of historical observations. And these analytics can generate geospatial content like your stream layers, feature layers, and map image layers, which can then be leveraged throughout the whole ArcGIS platform and client apps like the apps, the APIs, and also desktop applications. So you can then derive additional insight and situational awareness. So a lot on the feed. So the first step is simply accessing your sensor data and bringing it in. So that whole ingest part. So configuring feeds, as we saw, is an easy-to-use guided workflow that lets you work directly and seamlessly, to connect these external sources of observational data. They automatically derive the schema of the data. So you saw there's no kind of data mapping or anything. Automatically derive the schema, and then you can revise it further to meet your own data model on the fly. And you can also just simply add into the map immediately to see the real-time information and combine it with other data. So essentially, this is both system integration and situational awareness configured in minutes without writing any code. Bringing data in with feeds is just the first step. So with real-time analysis, you can do more than visualize your sensor data. You can immediately put it to use. So a feed is an input to a real-time analytic, which can be used to transform, enrich, and detect. Real-time analytics are a flexible model building capability, and they let you combine tools and take different kinds of actions. So you can store the sensor observations over time to a feature layer, send notifications and alerts, or even send commands and triggers to external systems to actuate behavior. So think of these real-time analytics as providing the processing horsepower to your IoT sensor workflows. So instead of requiring custom-built applications that need to incorporate complex streaming analytic code bases, any end user here can assemble an end-to-end workflow to detect incidents and capture data. Real-time analytics process each message from a feed continuously as they arrive and can leverage static data sources as well to serve as things like geofences or enrichment data. You can combine different tools together in a workflow to ask any number of questions and associate different output behavior with each one. In some cases, you might store data, whereas in others, you might send alerts or send a command to a third-party system. Real-time analytics are useful when your decision timeline is operational. That is, when you need to know about something and take action immediately. Beyond the real-time visualization analysis, you can also work with the information that you store over time. So feeds bring in and visualize real-time data, and these get used in the real-time analytics for immediate awareness of incidents. Real-time analytics, of course, can store these observations over time to a feature layer. As data arrives in real time, these historical data sets can grow to large volumes very quickly. So even if you just have, say, 20 per second. This grows to over 1.7 million records within one day. So for that reason, it's been designed to grow with you. So it includes fully configurable big data analytics, so you can process this information for trends. And these big data analytics can be your traditional ad hoc analysis, but they can also be scheduled to and run in near real time to support different workflows. And they can be used to analyze the data that you store over time as it grows and becomes more and more unwieldy to work with. So you can run the analysis either on feature layers with data that you have stored over time, or cloud big data stores that are fed from other organizational systems. So much like the real-time analytics, you can stitch different tools together in an overall automated process and create multiple information products at the same time on the same data. Now, the big data analytics, these are useful when your decision timelines are tactical. So that is when you need to make a decision regularly based on standard practices, or strategic when you need to learn over time and adjust larger approaches. So overall, there's extensive support for different real-time and big data systems in various data formats. So Esri's developed these aimed at covering the major commercial IoT platforms as well as common real-time messaging technology. For example, there's MQTT that can be used as a bridge to bring in vehicle tracking data, and an Azure or AWS IoT hub could be leveraged to access data from a SCADA system and make it available externally. And polling website enables you to access any number of sensor vendor APIs. There's also a wide variety of spatiotemporal analysis tools included. This includes tools for summarizing data, detecting different kinds of incidents and behavior, analyzing patterns, and leveraging spatial proximity. And these are available through GeoAnalytics Server and Velocity. This includes tools and concepts that focus on tracking and movement analysis, like calculating motion statistics, summarized journey and trip information, and snapping tracks to a road network. All of these tools can be used in big data analytics, and they can operate on a single message at a time or also work in real-time analytics. So now I'm going to hand back to Fran for another demo, putting it all together. Fran.
Cool. Just share my screen. So I'll start with a video. And what we see here is Wellington City. And as you can see, there are many different sources coming into this map. And I was going to give you a second to see if you could identify what they are, but it's very clear on the screen. So we have weather data, we have global event feeds, and we have public transport, vehicle location, and status. So as you can see, if I play this video, the dots in this map are moving as the data updates. So in this case, the Metlink data, specifically the bus locations, get updated on a 10-second interval. But how do we create this? So these layers specifically, if we go to velocity, we have already added our data sources. So we have weather from Met Service API, we have public transport GTFS data from Metlink, and global event data from Signal. So in this example, we've used the Signal events in conjunction with the Metlink GTFS to not only visualize the moving buses that are updated every 10 seconds, but also to get information out of these features. So let's see what analysis we've done. So we've done a bus alerting system real-time analytic using the bus locations and the Signal event locations. So first we started by filtering the features by attributes or geometries to highlight the buses that happen to be in close proximity with the reported event from our Signal event feed. So we just want to see the buses that are within 500 meters of said event. And we've created a buffer and filtered the buses that are close by. And to complete the alerting system, we've added an extra tool, which is called an HTTP endpoint that's connected to Microsoft Power Automate. And this allows the system to send out emails and inform the relevant people with the bus information. And that would look like this. So the outputs that are generated in Velocity can be used like any other layer across the platform, showing real time in 3D, for example, which I'll show this video. So here using the same MetLink data, but now we can see the ferry in a 3D view. And in this case, we've also created some analytics. So that's just one example of how you can use this data in a different application. But we can start answering questions like the where, the when, and the why an event is happening using ArcGIS Velocity for historical analysis as well. So you can travel back in time and study the route conditions or query the bus information when local events pop up. And we can also store this information and use it for other historical trends. Go back to the video. To discover the emerging hotspots of buses in the city, for example, as you can see here. In just a week worth of data, as you can see on the screen, we've collected over millions of bus locations. And as this information gets more and more voluminous, we can start using the big data analytics to discover more information within the data. So here in the big data analytics, I'll go to bus probability. So here we're looking at an analysis to calculate the chances of hopping on a bus when it's at full capacity. So first, snapping the bus features to the network, which is LINZ New Zealand roads addressing. We can define the date and time that we want to do the analysis on. And then we can calculate the probability of hopping on a bus that's full. So the result of this analysis gives us a user-friendly map that indicates the chances of hopping on a bus during weekday morning rush hour, because the bus has arrived at full capacity or only has standing space. So this can be a very useful tool for end users, but also for transport and planning teams. So this is just another example of how Velocity may be used to ingest real-time data and create real-time and big data analysis to discover more information that's hidden in the data. So I'll pass back to Dan.
Okay, no, there's some really useful examples there, and I think that what we just saw could be applied to so many different use cases and industries. Also combined with something like ArcGIS knowledge to do graph analysis, you can really start digging into some of that historical data to understand some of the trends and patterns and why things happen. Thanks, Fran. So switching gears a little bit, if my slides decide to work. Yeah, there we go. We've looked at the server-based technology, ArcGIS Velocity, and talked about GeoEvent server as well. But I guess, did you know that ArcGIS Field Apps can serve as a real-time data source? So with the mobile apps, they support location sharing, and these are things like ArcGIS Field Maps, ArcGIS Quick Capture, and ArcGIS 7123, as well as ArcGIS Indoors Mobile when it's paired with ArcGIS Indoor Positioning System. So these apps can be configured to allow users to share their real-time location through ArcGIS. So you can then monitor and display this location sharing data as a real-time feed. So the data can be used to improve awareness and task work more effectively, coordinate work based on proximity, and also, of course, keep people safe in emergencies or in-line worker situations. So this can provide real-time insights on teams' locations, both indoors and out. And there's also geofencing alerts or location-aware notifications, and these trigger when entering or leaving predefined areas. So this is really cool because geofencing in ArcGIS allows users to create these virtual boundaries, the geofences, around specific areas, or they could be created dynamically where, say, there's an outage on a power network, for example. And this is available indoors or outdoors as well. When people, vehicles, or assets enter or exit these predefined zones, automated actions, notifications, or alerts are triggered. So this enables the real-time monitoring and, again, that smarter decision making. So Fran will show us how to do this in a moment. Also, location history. So you can monitor and analyze movement patterns over time for insights. And with secure sharing options, the user can control who can view or access their location data with configurable permissions. Authorized managers and supervisors can use a web app to visualize and analyze the track data. So I'm going to hand that back to Fran to give us a quick look.
Sweet. So I'll start again with a video of what Dan has just talked about, which is the geofencing. So here we see a field worker entering a geofence, which is alerting him that he's approaching a work zone. And once he's approached or entered this second geofence, tracks will be saved. So his location sharing will be turned on. So in this scenario, we have two geofences, one just to send a notification, and the second one to activate location sharing. So as you can see on screen, once we enter that second geofence, locations, we get a notification that tracks will now be saved. And as the worker keeps moving, we start seeing that the path that he's following. So in a moment, I'll show you how to configure this from the Field Maps Designer. But as you can see, you're getting your notifications. So even if you're driving, you still get your notifications that you can look back on. So cool. I have a map here that's in the context of pest control. So here I have my traps that I've placed. I have river lines, and I have map nodes that are placed as polygons. And these are what I'm going to use as a geofence. So this is the map I'm using in my Field Maps project. So if we go to geofences here, I can set up a new geofence, and I will call it hazard. So you have to select the layer that you want to geofence, and this doesn't have to be a polygon, but I will choose a polygon in this case. And my map nodes, I've configured them to either be information or hazard. So I can filter this by attributes so that I only geofence the hazard polygons. And then I can set either location sharing for this geofence or location alert. So I'll choose an alert so that my field workers get notified. And I can also set a buffer so that when they're approaching the area, they get notified, but I'll leave it without a buffer. And I can also notify them when they're left the area. So very easy to set up a geofence. In this case, I've already done it. And I've used the same polygon for location sharing. So I get notified, but at the same time, my workers' location will start sharing once they've entered the area. But like I said, these don't have to be polygons. In this example, I also geofenced these river lines for my field workers when they're placing traps to get notified that they're within 15 meters of a river. And to keep this in mind, because rivers are natural barriers for possums, but there are pathways for stoats. So this is something they need to consider when placing the traps. So that was one example of geofencing and location sharing in field maps. Now I'll pass back to Dan.
Excellent. Thanks for that, Fran. I'm sure there's a number of you on the webinar today that are seeing that and think of a number of different use cases where that could be applied for mobile workforces. Now, I'm just conscious of time, so I'm going to whip through my final 3 slides fairly quickly. But as well as what we've seen here today already, there are additional examples. Here are some additional examples of ArcGIS apps and tools that can be used to visualize and analyze the real-time data. So, we all know ArcGIS dashboards. That lets users visualize, monitor, and report on real-time data that have been ingested and processed. So these dashboards, as we know, are great for delivering key insights to stakeholders at a glance. ArcGIS GeoAnalytics tools, these are available in ArcGIS Pro and can be used to analyze massive amounts of historical data accumulated for real-time feeds. ArcGIS notebooks, so this is the Jupyter notebook environment that allows data analysts and data scientists to write analysis routines that apply GeoAnalytics tools to large historical data sets. ArcGIS Solutions, so check out the ArcGIS Solutions site for apps designed to apply real-time capabilities to specific use cases. So one example was the Watch Center, which was that first demo that Fran showed us. And for developers, ArcGIS also provides tools that allow developers to build custom applications that leverage their real-time data. So these include ArcGIS Max SDK for JavaScript. This SDK lets developers build custom web apps and connect to real-time streaming data layers from ArcGIS. And there's also the ArcGIS Max SDK for native apps. So these SDKs provide additional real-time capabilities that aren't available in the JavaScript SDK. So they allow developers to build apps that support real-time location sharing, like Esri's own mobile apps, client-side geofencing and alerting, and local data management and caching. And there is one other piece of software which can be used in real-time workflows, and that's ArcGIS Mission. This is a tactical situational awareness solution that leverages peer-to-peer communication to share messages between team members. So this gives users a way to securely share real-time alerts in the field. ArcGIS Mission actually leverages its own real-time server technology that does not depend on ArcGIS Velocity or GeoEvent server. And of course, ArcGIS can read multiple data formats as a source of location directly. So these include, the classics that you see up here: web feature services, KML, widely used for sharing geographic data, your GeoJSONs, which is a lightweight data format based on JSON, used to represent geographic objects, and your GPX, your GPS exchange format designed for exchanging GPS data, waypoints, routes, and tracks. So these formats allow that seamless data integration supporting various spatial analysis, mapping, visualization tasks. So the screen grabs you see on the screen here show adding a KML file into an ArcGIS online map. And just wrapping up, ArcGIS provides APIs that can be exposed through various interfaces to enhance automation, integration, and spatial data processing. So there's Python notebooks within ArcGIS for that environment for scripting and geospatial analysis. Fran mentioned Microsoft Power Automate earlier, so users can build workflows that automate your GIS tasks and integrate with other business applications. Also, things like Azure functions that allow ArcGIS capabilities to be extended into serverless cloud environments. And additionally, there's the Data Interoperability Extension, or FME server that supports advanced data transformation and seamless integration between ArcGIS and diverse data sources. And this can facilitate some quite complex data workflows. So these interfaces allow users to streamline geospatial operations across different platforms and systems. So here are some valuable resources to continue your journey with real-time GIS. So simply scan the QR codes to access. I believe we will be sharing this afterwards as well, so don't panic if you can't get them all. ArcGIS documentation is always a great place to start. So this is where you can get detailed guides and technical documentation on configuring real-time GIS solutions. Tutorials and training, where you can explore step-by-step tutorials and online courses to enhance your skills with live data streams in ArcGIS. Join the community. So join discussions with GIS professionals, ask questions and share your experiences with the Esri user community. And there are real-time community meetings as well. So in the real-time visualization and an analytics group, they have scheduled meetings in there. Blogs and case studies is a great way to stay updated with the latest trends, the insights, and real-world examples of real-time GIS in action. For example, on the link there, you'll see the most recent blog is a how-to on real-time change detection with arcade track functions in ArcGIS Velocity. So some cool stuff. So scan the codes to dive deeper and unlock more tools, tips, and inspiration to make the most out of real-time GIS. So we've covered a lot of ground today, from workflows to real-time GIS capabilities and best practices. So now it's your turn. So if you have any questions or need clarification on anything we discussed, this is a perfect time to ask, although we've only got 3 minutes. So whether it's about setting up real-time GIS workflows or using ArcGIS tools or specific challenges, we're here to help. So let's dive in and address your queries. So let's see what we have. Sorry, just trying to drag my windows. Frank, can you see, are there any questions in there?
No questions at the moment.
No questions. All right. I hope that means we've done a great job and we've answered all the questions as we've gone. But that's great. If there's no questions, we can wrap up. So thank you all for joining us today. We hope this webinar has provided valuable insights into the power of real-time GIS, from understanding the basics to exploring the workflows, the ArcGIS capabilities, and some tips along the way. So as technology continues to evolve, harnessing real-time data will become even more critical in driving timely decisions and creating innovative solutions. So we encourage you to explore the resources we've shared and apply the capabilities that you've seen today to your own projects. Be excited to see these being presented at the next regional user conferences or the annual user conference. And if you have any further questions or need additional support, please reach out to your Eagle account manager or technical advisor. Thanks again for your participation. Happy mapping. Mā te wā.